In this video, we're going to take a look at the first of our Intro to Data Science sections on basic descriptive statistics. Now, as you work towards becoming a data scientist or just someone who works a lot more with data in general, one of the ways that you'll typically get to know your data, which is an important part of data science, is to use statistics. And statistics are a great way to describe data, a great way to summarize data as well. And here we're just going to take a look at some very basic statistics. Now, some of those basic statistics include finding the minimum of a set of values, the maximum of a set of values, a range, which is simply the minimum to the maximum value. That's a spread of information. And also simple things like the count of the total number of items in a collection of values and the sum of those values as well. In this section, we'll focus on the minimum, maximum, and range, and we'll take a look at count and sum as we move forward into later lessons. Now, there's also other types of basic descriptive statistics called measures of dispersion. Some people refer to these as measures of variability. And like the range, these help you figure out how spread out your values are. So in the next lesson, when we get to its Intro to Data Science section, for example, we'll take a look at the measures of dispersion called variance and standard deviation. So again, we're going to focus on minimum, maximum, and range here. So first, let's go and switch back to my terminal window. And for this example, we're actually going to be using the script fig02_02.py. And before I take a look at the code with you, let's go ahead and execute that script a couple of times. So IPython followed by the name of the file, and as you can see, it's now prompting me to enter an integer. So let's say I enter 12, and it's asking for a second integer, so I'll try 27, and a third integer, so I'll try 36. And before I go ahead and press enter here, what we're going to do is find the minimum of these three values using the script that we're about to take a look at. So as you can see, the first value that I had input up above here was the smallest of those values, and it seems to have recognized that. Let's rerun the script putting the number 12 in different positions so that we can make sure that the script really does always find the minimum. So I'll execute this again, and this time we'll do 27, then 12, and then 36, and we can see it still figures out that the minimum is 12. And we'll execute it one more time with 36, the largest value first, then 27, and then 12, and you can see we still find that the minimum value is 12. So let me switch over to my text editor here, and we'll take a look at the script that implements what we just looked at. Now, I'm doing everything manually in this script. After we get through the script, I'm going to show you that Python has some built-in capabilities that we could have used as well. Since this is only our second script, I just want to rehash a couple of the things that we talked about previously. What you're seeing displayed in green, preceded by a hash symbol or pound sign here, is a comment. Again, every one of our script files starts with a comment that contains the file name so that you can easily find that file in the corresponding lessons examples folder. Every script you create should start out with a doc string, which again is always going to be a triple quoted string stating what the purpose of the script is. And for more complex scripts, your doc string could be full paragraphs and even many paragraphs of information in between the starting and ending triple quote delimiters. Now, we saw earlier in this lesson that we're able to use the input function to obtain something from the user at the keyboard. Remember that input takes as its argument a prompt, which is going to get displayed to the user to tell them what to do. The user then responds to that prompt by typing something and pressing enter, and the input function call, the input function call is going to return that to us as a string piece of information, but because I want to do numeric comparisons here, I'm going to convert that to an integer. So we do that 3 times here for number 1, number 2, and number 3, and I'm assuming in this code that the user is properly entering numeric values, otherwise this may not work the way we expect it to work. Of course, if I were to type, for example, the string hello and try to convert it to an integer, as I showed you earlier in this lesson, you'll wind up with a value error. Now, for the purpose of this little example, like I said, we're calculating the minimum of 3 values manually, and to do that we made a simplifying assumption here. We assumed that the very first number that the user input into our script, it was the minimum value, so we simply assigned number 1 to minimum. Then we went ahead using the if statement that we saw earlier in this lesson and determined whether either of the other 2 numbers that the user input were less than that value. So if by any chance number 2 was less than what's currently in minimum, then we assign number 2 to minimum. And if by any chance number 3 is less than whatever's currently in minimum, then we assign number 3 to minimum. After those 2 if statements, we're guaranteed that the variable minimum contains the smallest of the 3 values, so we went ahead down here and used a print statement to display minimum value is, followed automatically by a space because we have a comma separated list of values that we're displaying with print, and then we displayed the value of minimum as well, and you saw what the results of that were. Now, finding the smallest of a bunch of values you might think is a relatively common operation, and it turns out that indeed it is a relatively common operation. So what I'm going to do here is open up the IPython interpreter once again and talk about the fact that there are built-in functions called min and max that you can simply hand a comma separated list of values, and those functions will figure out the smallest and largest values for you automatically. So you don't have to do anything special to access those in your Python code. All you have to do is type their names. So min is a built-in function, and if I hand it 36 and 27 and 12 as a comma separated list of arguments, it will automatically, once I press enter, call that function, pass in the 3 values, and as you'll see, the result is indeed 12. And similarly, let me just recall that statement and edit this to be max. There's also a built-in max function and several other functions like this, by the way, that is capable in this case of figuring out the largest of the 3 values. So if I go ahead and hit enter, you can see that indeed we do get the value 36, which is the largest of the 3 values that we provided as the comma separated list of arguments. Now, with the minimum and the maximum, we can also determine the range of values, which is one of the descriptive statistics that we wanted to talk about. In this particular case, we can see that the range of values that we had passed into these 2 functions is 12 through 36. So the range is simply the minimum through the maximum value. Now, unfortunately, the range is not a great way of determining data distributions for the following reason. Let's assume we had 100 different numbers that we were working with in the range 12 to 36, but we had 99 12s and 1 36. The range doesn't give us a sense of how that data is actually distributed across the range. Similarly, we could have 1 12 and 99 36 values, and again, we still wouldn't have a general sense of how the data is actually distributed. So as we proceed through our Intro to Data Science sections in subsequent videos, we'll talk more about descriptive statistics that help us understand the spread of those values. Now, there's something else I want to talk about in the context of min and max here, and for that, let me switch back over to the PowerPoint slides. Min and max are actually examples of a little bit of functional style programming in Python, and specifically they're a functional style programming concept called reductions. A reduction is something that actually takes a whole bunch of values and reduces them down to a single value. And one of the benefits that you get out of using reductions like min and max and other functional style techniques is that they can help you write code that's more concise, clearer, and easier to debug as well. So if I go back, for example, the script we were just talking about, obviously one call to the min function with 3 arguments is a lot easier to understand than all of this highlighted code that I am presenting to you as part of this script here. And of course, if I have lots of statements and I make an error, it's going to be harder possibly to find that error than if I have just a single function call. In general, if there's a function built into Python or one of the Python standard libraries that already does what you need to do, rather than writing all the code like I did here, you simply call the function and get the results that you need using these pre-tested, predefined functional style capabilities. So min and max are predefined reductions. Again, they reduce a collection of values to a single value. Some of the other common reductions that we're going to take a look at starting in the next lesson are things like the sum of the values. So when you add together all of the items in a collection, you get a single result. Same thing for the average of those values. And as we discussed a few moments ago, there are other measures of dispersion or measures of variability which are also common reductions: the standard deviation of a set of values and the variance of a set of values, both of which we'll talk about in subsequent Intro to Data Science sections.